Hello and welcome to the video tutorial for specification 2, choosing the right functional form for Econ 4650. The objectives of this video tutorial are that you will be able to enter different functional forms of regressions in R, which is what we're going to review right now. Hello and welcome to the specification 2, choosing the functional form video tutorial. So this tutorial is going to walk you through different functional forms in R for regressions, and I'd recommend reading the chapter before you watch this video, the chapter in Sudenmund, um, and also reading the first 2 pages of the text guide that comes with, or that kind of accompanies this video, that's available on the course module on Canvas, because it'll be helpful in kind of explaining the theory behind what we're doing here. So anyway, the first thing we're going to do is go ahead and bring in some Boston housing data to use for our example. So bhouse, we're going to say read.csv, and we're going to bring in the data from a website. So http content.csbs.utah.edu/tilde/fouls/econ 4650 /data with capital D /bhouse.csv. Great. And we're going to say header equal to true, and we're going to bring that in, right? So let's look at what we have here. So we got a bunch of data, so we're going to pay attention to just a few of these, right? So our left-hand side variable is going to be MEDV, which is median value for owner-occupied houses in thousands. We're going to pay attention to CRIM up here, crime, that's per capita crime rate. We're going to pay attention to room, that's average number of rooms in the houses there. We're going to pay attention to age, which is the, I think it's the proportion of owner-occupied units that are built before 1940. And we're also going to pay attention to, I don't know if I said NOx already. NOx is nitric oxide parts per million. Yeah, oh, and then later on we're going to pay attention to CHAS, or I'll just call it Chase, and that's a dummy variable for whether or not the property, the house property, borders the Charles River. So we'll get into this here. Let's set up a level model. Okay, so you should recognize this. This is the kind of model that we've been working with. So we're going to say LM median value, so MEDV. On the left hand side and the right hand side, we're going to have the crime rate per capita. We're going to have the proportion of owner occupied homes built before 1940, and we're going to have the nitric oxide number, and we're going to have the average number of room number, right? So we're kind of building a regression here for median value of homes. And we're going to say data equal to bhouse, so it knows where to go get it. There. And we're going to say summary reg1 and look at what happened here. So basically, for example, in this regression, when you have an additional room, or the value of the average number of rooms goes up by 1, you're going to add about $7,900 to the value of the home. Okay, so that's a straight up level model. So now we're going to do a log model, which is going to give us information in terms of elasticities, right? So we're going to say reg2 is LM log of median value for your left hand side. Your right hand side is going to be the similar values we did before, but just logged. So log of crime, log of age, log of NOx, and log of RM, right? And data equal to bhouse. And let me just check this before I hit enter here, make sure we got it all. Great, so that's reg2, so let's look at this. And so what you're seeing here is that of the values we ran, we have 2 that are significant, and 1 room is, or log of room in this case, shows us that the room value is elastic, and that if you raise the room by 1, the value of the home, or sorry, if you raise the room by 1%, the value of the home would go up by 1.7%. And crime here, you can see, similarly is significant, but it is inelastic, as it has a value that's saying that when the crime rate is going, or changing by 1%, it will affect the median value of the house by less than 1%. So we call that inelastic, right? So now let's look at a log level model. So we're going to say reg3 is lm log of MEDV on the left hand side, and on the right hand side we're just going to have our regular variables here. Make sure I did that right. Looks pretty good to me. Summary of reg3, and so here what we're going to see is that you can interpret this as for example, if you get an additional value of 1 room, you can interpret this estimate coefficient as a % change in the median value. So an increase in the room value by 1 will lead to a 28 or 29% increase in the value of the home. Okay, so that's kind of cool. That's yeah. So now we can do a level log example. Reg 4 is going to be equal to lm of MEDV. So we're just doing straight up variable there, and then crime plus age plus NOx plus log of RM, and data equal to B house, right? So there's that, and looking at that, we can see here that if so, the interpretation of this is that if you have a 1% increase in the number of rooms, you'll see a $459 expected increase in the value of a home, because MEDV is in thousands, and so when you have like the interpretation in this case of the level log model is that the % change in the x variable that you have logged, in this case rooms, the % change can be interpreted in light of the estimate as just a straight number. So I know that wasn't the clearest way of saying it, but basically, again, if you have a 1% increase in room, you're going to see a $459 expected increase in the value of the home. So this regression is showing us the sheer numerical value of the home change in relation to a % change in the x variable. Okay. And now we're going to talk about dummy variables. So in the Boston housing data, there's a binary variable called Chase. So we're going to add that to the first model. So we're going to say reg 5 is lm MEDV on the left hand side. On the right hand side, we're going to say Chase. Chase. And then the other ones we're using. RM B house. And then summary of that. So you can see here that when the dummy variable is a 1 and not a 0, the value of the home seems to go up by about $4,777. There's another way to do this in R. The dummy variable is like a categorical variable, right? So it's like it's either 1 or it's 0. It's either off or it's on. And you can tell R to treat it like a factor. And in this case, R should have already been doing that. But anyway, if you're ever not sure and you're dealing with dummy variables, it's important to let R know to treat them as factors, and you can do more research. Research on this yourself in R. It's kind of tedious to explain here, but anyway, the command is as factor, and it's in the family of the larger commands of factor. So there's lots to read up about that if you Google that command. So here we'll do reg6 as lm medv on the left hand side, and then on the right hand side as dot factor chase plus crim plus age plus nox plus rm, and data equal to b house, right? And we can do a summary of reg6, and you'll see the same results that we got before. So that's great. So now we can do an exercise where we interact rooms and river adjacency, right? So this is like going to be a dummy slope variable, whereas the last one was serving as kind of a dummy intercept variable. So let's see how the value of additional rooms on homes adjacent to the river differs from those not adjacent. So we're going to say reg7 is lm medv on the left hand side. On the right hand side, it's going to be chase plus your interaction term here, so chase times rm, and then plus crime plus age plus nox plus rm, and the data is equal to b house. And then we're going to do summary of reg7. And so we can interpret this as saying that basically the dummy variable will affect the slope, but not by that much, right? So if you've got a room, like, so if you look at the room variable by itself, so the room variable without the effect of being by the river, you're looking at like a change on the value of the home of $7,668, right? However, if you have a home and it's adjacent to the river, the marginal value of adding the room is going to be only adding $111 to that. So our dummy slope variable is going to change the slope, but not by that much. Cool. So again, this was an interaction of rooms and river adjacency. A cool way to illustrate this is to look at how the model was created. So we can do this if we type in model.matrix. We can kind of peek into what R was doing here. Just type this in and tell it we're going to look at rows 230 to 240. So say 230 colon 240 with a comma. And then if you hit enter, you can look down here and you can see how the interaction variable only takes effect when the chase variable is non-zero, right? So when it's 1. So that's kind of giving you an idea of that when or of like how this is working in the regression as a dummy variable to affect the slope, right? As opposed to a dummy intercept variable, which would just change the intercept and not be interacting with any of the x variables. The book does talk about that a little bit more on page 208. I believe it's 208. It might actually be Okay, so it's more like 208 through 210 and 211. But anyway, all right, so that is the video tutorial. Thank you. And moving on from here, assignment 6 is available in Canvas in the specification 2 module.